tutorial on FRCSim. So today we're going to be doing a C++ debugging video. So this is going to show you a common technique for debugging your simulation. I'm actually going to work through an example that I found while I was working on simulation. The issue should be fixed for you, but if not, this will be a convenient way to learn how to fix it. But more importantly, it's going to show you how to use the tools and some basic logic on how to start debugging. In this case, I'm using the PackGoat example robot, so that can be found in the Insert tab of Gazebo under either WPILib simulation, or I believe also under the within the Gazebo online repository, which appears as http://gazebosim.org/models. So once you've got that in, you want to get some code. I'm going to be using the Gyro C++ example. You may have to modify it to get the port numbers right for the robots, but that's as simple as looking in the SDF file for that robot. I've already fixed them, so they all work. Okay, so the example code here is pretty simple. It asks for our joystick input forward or backwards, and uses the gyro to drive straight. So the problem we're going to see if I run my program, of course that can be done by right-clicking Run as C++ Simulation. Another faster way to do it is just to run the executable. Here I'm in my workspace, my project, and then the Linux simulator directory. So with that running and everything enabled, you can see, despite moving my joystick forwards and backwards, the robot remains stubbornly in its place. So the first thing you should really check when your robot is just sitting still is whether any messages are actually being sent to the motors or from the driver station. So why don't we open up a new terminal, and we're going to use the GZ tool to debug this. We're going to want to use the topic command, and we're going to start with the -l argument, which says just list everything. Okay, so there's a lot of stuff. Let's see if anything is being published to it. So you can use -i, which is information, and let's check, for example, the PWM1. Why not? Okay, so things are subscribed and published to it, and if we try with -z, we can see, in fact, messages are being sent. So if messages are being sent and the robot's not going anywhere, that means the messages must contain something funky, but probably 0. So we think we're sending 0 to the motors. This would be the point at which you go and blame your code. So we're going to use GDB, which is one of the classic Linux C++ debuggers. It's a really great tool to learn, even if it's not as powerful as maybe, or easy to use rather, as one of the ones provided by your IDE. It is still a really great program to use. So you're going to run your program or your robot code, which of course compiles to the executable FRC user program, like I said, in the workspace /project/Linux simulate folder. So you just run it like that, and then if you see something like reading symbols done, then you're good. If not, that just means you're missing debugging symbols, and that's a settings, Eclipse project settings things that could be fixed if you somehow messed that up. We're going to start by typing start. So start says, okay, enter this program, but stop as soon as you reach the first line of code. So in this case, that's going to be the macro that we have here at the bottom of every robot code, or all the C++ code. This expands to main, so it's really just the first line in main. At this point, GDB knows about every single function in all of the files related to this program. So we can do things like set breakpoints. So a breakpoint is simply a spot in the code where you want to stop every time you reach it. In this case, since I'm suspicious about motors having weird values set, why don't we try braking every time we set a speed of the motor? Seems to make sense. So we can use B or break to set a breakpoint, and we can tell it the function name. So in this case, I'm using talons, so I want talon. And then if I hit tab, it will list all of the options here, and of course we want set. From this point, we can just type continue, or just C for short. This will let everything in the program run as normal until we reach talon.set for the first time. So if you want to look around at what code is being run here on this line, since it only shows you, one line, you can type L, and that shows you the current line plus some surrounding lines for context. In this case, you can see the talon.set function just calls set speed, but speed is what we're interested in here, so how can we figure out its value? Well, you might be tempted to put a print statement in your code, but it's much faster to just type print or p speed. There we go, 0, just as I suspected. So at this point we want to figure out why speed is 0. So speed here is an argument to this function. So whatever called this function called it with 0. We can figure out which function called it by typing up. That moves us up what's called a stack frame. So this basically goes to the parent function that called this instance of set. Here you can see if I type L, this is the code that's being run. In this case, you can see the offending line is right here. So something about this formula is giving us 0. So why don't we inspect its elements by using print, not 0, not 0. In fact, that's actually very similar to what you'd expect from a joystick, which is quote at 0. So it's really small, but it's not 0. So then obviously the error is with M inverted motors. Aha! So you can see all of the elements in that array are 0, which is going to cause the problem. It's going to set all the motor speeds to 0. Now this is an internal bug. This is something that we screwed up. You don't really need to worry why it's 0, but what I can show you is how to make it not 0. If you have an updated version of WPILib, then you won't have this problem, but if you are curious or you hate updating for some reason, there's an easy fix, which is just to explicitly set all of the motors to be not inverted, or inverted if you're into that. This is going to explicitly set all the elements in this array to 1, so this will look like 1, 1, 1, 1, 1. And then this will be 1, this will be whatever it was, and we should be good to go. So I'm going to make this change here and prove to you that it works. So you can build either by clicking the little build guy here, or if you're a terminal guru, just by typing make FRCSim program. It does exactly the same thing. So once we finish building our program, we're going to run it again and hopefully see Paco drive around a little bit. Again, we can run it just by typing / and then the program. / is just a Linux thing. It refers to the current directory, and this is the file we want to run inside of it. Well, everything looks good. And now, when I move my joystick forwards and backwards, lo and behold, the robot drives. It doesn't look like it drives straight, but that's a matter for a different video. I hope this has been helpful. I hope you've learned a little bit about GDB. There is so much more that GDB is capable of. It's incredibly well documented as well. There's lots of examples on how to do complicated breakpoints or how to step into and out of functions. I didn't even cover the next or end command, which moves to the next line of code. But there's lots of great videos on all of those things. This should at least get you started. So good luck with debugging all of your C++ programs. If you have any questions, write them in the comments below.